Hey, Harpreet, can you share your screen?
Give me a second.
All right, so we'll go ahead and get started. Hello and welcome to our webinar, Continuous Delivery with Jenkins and Puppet, Debug Bad Bits in Production. My name is Alyssa Tong and I'm with CloudBees. Today's webinar is presented by CloudBees and Puppet Labs. CloudBees is the Jenkins Enterprise experts and the leading provider of Jenkins solutions for continuous integration and continuous delivery. Harpreet, can you go on mute for a second? Puppet Labs is the leader in IT automation software for proactively managing dynamic infrastructure and scaling from tens of servers to thousands, both on-premise and in the cloud. Our presenters for today are Harpreet Singh and Reed Vanderweel. Harpreet is Vice President of Product Management at CloudBees, and Reed is Technical Solutions Engineer at Puppet Labs. In this webinar, Harpreet and Reed will address the issue of identifying the source of where bad bits came from when production instances get tainted. They will show you how they solve this issue to provide an end-to-end visibility from development to production. Next slide, please. Before I pass it over to Harpreet, I'd like to cover a few housekeeping points. If you have any questions today, please feel free to input them in the Q&A window throughout the presentation. We will cover the questions at the end of the presentation. Any questions that we don't get to, we will cover it in our follow-up email. Also, today's webinar is being recorded and we'll send out the recording to everyone who registered. So at this point, I'll hand it over to Harpreet.
Thank you, Alyssa. And good morning, good afternoon, good evening. Thank you for taking time from your busy day and joining me and Reed today for this webinar. And before I start, let me sort of roll out how the agenda for the talk looks like. There are a number of people on this webinar who are familiar with Jenkins but aren't familiar with Puppet and vice versa. So me and Reed will briefly give you an overview of what these tools bring. And since we both have to make our mortgages, we'll also talk about our enterprise products from our respective companies. The next aspect is about, then we'll talk about two use cases. A lot of people are trying to deliver continuously, and CD is the buzzword these days, and they're using a number of tools. And we'll talk about a use case with Jenkins and Puppet and how the open source Jenkins community has worked with the Puppet folks to build a continuous delivery pipeline in open source. And we'll also talk about what we have done as teams together to help you sort of connect these tools from these tools together. And that pretty much sums up the agenda. So with that out of the way, let's set context first. All of you here are here because your company has this unique product, or at least a product that has its unique set of capabilities that differentiate it from the rest of the clones in the market. And the idea is to get your product to market fast. Time to market today really matters, right? And everybody is looking for that edge to take your product and deliver it faster. The way this used to work in the old days was there was a dev team that was working in its own silo. It would do its own stuff, and it would hand off the bits to the ops team. The ops team would come in and deploy that, and it would use, so the dev team is using tools like Jenkins, the op tool is using tools like Puppet, and if everything works fine, things are deployed and things are perfect. And the whole end-to-end cycle time would pretty much be months, or if not, years. And with the new mantra in the industry about DevOps and continuous delivery, the idea is how can we bring these two worlds together such that the ops team can actually look over the shoulder of the dev guy and say, hey, this is what you're giving me, this is where it lands up, and the dev guy can actually look the other way as well. And as we talk about this, the DevOps days, and if your product releases, just because your pipeline wasn't, there wasn't really a great way to set these pipelines up, what often happened was your product releases were delayed. And if you were lucky, that would cost you, a few $1 million in the market. If you were unlucky, it could potentially be the kiss of death for your company or your product. And the whole continuous delivery movement has come about where it's sort of a meeting of the mind of development and dev and ops and the business side, where business has started looking at this pipeline and started saying, like, well, not only is my application my source of differentiation in the market, not only is that Apple unique in the market, but the whole infrastructure that takes this Apple to the market, that's a source of differentiation as well. And as business has realized that there is an increased amount of pressure on the dev and the ops team to make these pipelines and have these workflows that deliver things faster. So with that out of the way, there are two really big tools in the market that actually let you do this. So we'll start covering that, and let me get into the Jenkins side of the house. So for those who are not familiar, Jenkins is an open source tool. It's been there since, I guess, 2003 or 4, and it's a fairly the development is fairly agile. Actually, we end up with one release a week in open source. That's how fast and agile the community is, and it's sort of the de facto CI server in the industry. This is, depending on who's doing these kinds of surveys, you'll find Jenkins. There's a common thing. It's just a number, the percentage number that changes, but it's usually comes about that Jenkins is the most used CI server in the market. There are about 80,000 installations of Jenkins that are out there in the open. There are teams of size from 1 to in thousands that use Jenkins. So it's really a de facto tool. And this survey is somewhat dated. This is before the whole continuous delivery movement took off. But even then, you can kind of see that Jenkins is used for the entire dev to deploy lifecycle. About 50% of people are using Jenkins for deployment. We already knew that Jenkins is being used on the CI side of house. It's no surprise that it's being used for build, test, and deployment. What's great is actually in the survey that we did, we found that about 85 or 82 or 83% of people who are using Jenkins pretty much say it's mission critical for their enterprise. So it's really out there. Now, what makes it actually great is the philosophy of the founder, Kosuke Kawaguchi, who really believes in this extensibility mantra. And from his perspective, if you come back to the open source team and say that I need a functionality, and this functionality does not exist in Jenkins, his answer is, can you write a plugin for that? And if you can't write a plugin for that, that's where he make change. The team will make changes in open source that will enable you to write a plugin and plug into Jenkins. So what that's done is you now have this plugin ecosystem. At the last count, it was about 1,000 plugins. When I was doing this 2 years ago, there were like 300 plugins. So everybody has, every tool out there has a plugin that plugs into Jenkins. So if you're on-premise or running in your own private cloud, you can connect to, Git on the development side, Maven and JFrog, can connect to Swasta on the testing side, can connect to Puppet on the staging and development side and deployment side, or, you can connect to any number of tools like WebSphere or JBoss to deploy your application. And this same behavior is actually mirrored on the on the public cloud side as well. So you could talk to GitHub, no surprises there. And again, you can use Puppet to deploy stuff if you're doing this on Amazon or on Google Cloud Compute. Or if you're using PaaS out there, you can use Heroku or Cloud Foundry or any out there. So that's really what makes Jenkins successful. And where we come in is we have multiple solutions on Jenkins. So if you're looking at Jenkins as a service in the cloud, where you don't want to manage it, we run the Jenkins as a service. And if you're looking to run Jenkins on-premise, where you've been using Jenkins as you've downloaded Jenkins or using it, then you can run Jenkins Enterprise by CloudBees, which brings in certain enterprise plugins on top of Jenkins. And you can use Jenkins Operations Center, which lets you manage multiple Jenkins instances across your organization, and it becomes that single point or single dashboard into Jenkins within the organization. Now, if you are running on-premise and you want to connect to slaves in the cloud, we have a hybrid service. If you're running on the cloud and you want to connect back to services back on-premise, we have a solution that lets you connect that, so you can go either ways, and that's what we call hybrid. In terms of Jenkins Enterprise, and I'll be very quick on this one, what we do is we provide support on Jenkins open source core and all of the plugins in the community. So this is your typical, open source support model. So we have SLAs on, ticket resolutions, and then we have a set of plugins, an ever-increasing set of plugins that largely fall into four buckets. And there are plugins for high availability. So what it does is if your Jenkins master goes down, a backup Jenkins master comes up. There's plugins for, say, long-running builds, which sort of help you survive master failures, and your job keeps running, and if the master comes back up, your job kept on running. The more popular ones are the folders plugin, which helps you, divide your teams within folders, and then use that with the roles-based access control to provide sophisticated roles-based mechanism. So that's what we bring to the table. And today, when we talk about things, we will talk about some of the things we've done in open source as well as the plugins in Jenkins Enterprise. So let's get to sort of continuous delivery. So we already knew. So what happened in the last 5 or 7 years is, CI took off. People really got the value of, hey, I can actually take my source code, run my tests, do my QA, and push my binaries to a repository. And CI really makes that easy. And as the experience with CI grew, people started adding on more stages, right? So you started doing performance environment testing, functional testing, usability testing. And once all of that was done, you would push that to release and staging environment and production environment. So all this we kind of know can be done with CI and Jenkins. But what's interesting is all of these actually span different organizations. So it's not just one organization that's doing it. So what we like to think about is, it's one thing that if you give this to a dev guy, he's looking at this and he thinks of the local maximize. How can I improve my dev release? But what CD brings to the table is a new way of looking at things, which is not the local maxima, but the global maxima, which is how can I improve the end-to-end cycle time for releasing software. So it's really at that point it becomes the process. It's not a magical tool that brings and does something for you. So as you go across teams and you work out these processes, what becomes important is each of these teams has a set of tools that they use. And these tools are sort of make sense for that environment. And this is where actually Jenkins really shines with its plugin architecture, right? It can just connect into all these tools and it can span across processes and organizations, and that's how it enables continuous delivery. So that sort of sets the context for Jenkins and CI and CD and, from my perspective. At this point, I'll hand off to Reed to talk about Puppet. So Reed, just give me a moment.
All right, thanks, Harpreet. Looks like I have the ability to share my desktop now, so let me go ahead and, actually don't quite have that button yet. All right, here we go. So this is kind of from the Puppet side, this is the same sort of thing. It's an introduction to what the tool is. We're going to go spend the next 10 minutes or so kind of defining what problems Puppet solves and how it solves them. If Jenkins connects the dots, you can say that Puppet is a tool and a process for defining some of those pieces. So first, just an introduction to Puppet Labs. Puppet Labs is kind of leading the IT automation revolution. Our company was started in 2005 when our founder, Luke Kanies, who was a sysadmin at the time, the #2 contributor to the CF Engine project and a project manager for BladeLogic, two IT automation products at the time, was fed up with the state of available configuration management tools to the point where he wanted to create a new mousetrap. So he created a new tool that addresses today's challenges. Since then, Puppet has become kind of the de facto standard for IT automation. We have over 10 million nodes under management. We have deep partnerships with data center vendors like VMware and Cisco. And we have thousands of modules that extend Puppet's capabilities and best practices and advice to help you make the most out of what Puppet is. So over the past decade or so, IT ops has seen a massive infrastructure shift. Virtualization is the new normal. Cloud computing is increasingly part of the IT ops arsenal. Through these advances, operations teams are now able to add computing power faster than ever, are left with massive amounts of computing power, and have access to more software than ever. But they're also left with a seemingly insurmountable problem of actually making all of that new infrastructure do what it needs to do. At the same time, businesses are waking up to the fact that software can be a competitive advantage and are putting more pressure on IT to deliver better software faster. The opportunities are great, but to capitalize on that, some things need to change. The problem is, while development practices have changed significantly over the course of the past 2 decades, operations practices haven't really. Typically, the old way of doing things were manual configuration, where an admin logs into a server and edits a file, installs a package, makes a change. Maybe they set up custom scripts in Python or Perl or
other languages to automate some of that, but they're typically individual grab bags of tools. Golden images seem to bring a lot to the table, but it turns out that they're large and difficult to manage, and your stable of golden images grows uncontrollably if you have a lot of different variants that you need to deploy. Legacy tools, offered IT and op shops capabilities around compliance and making sure things were stable, but they weren't able to iterate quickly or using those sorts of utilities. So the old way of doing things doesn't work in a world where speed and agility are paramount. As the complexity of your systems increases, manual management of infrastructure in any of these ways isn't going to cut it. Manual management has real impact. It drags down the speed at which you can execute, your productivity, and the insight that you have into your infrastructure. Manual configuration, for example, servers start to develop personalities, depending on which administrator deployed them and how, at what period in time. So that has to change. Business demands better, ops has to adapt. To succeed in sort of the new world that we're in, ops has to go through a fundamental transformation. So this is where Puppet Labs comes in. Our software helps you make rapid, repeatable changes and automatically enforce the consistency of systems and devices across physical and virtual machines, on-premise or in the cloud. We help by automating the configuration and ongoing management of your machines and the software running on them
so that as sysadmins, you spend less time fighting fires and more time worrying about actually deploying great software. So many users start by using a tool like Puppet to help automate something like the configuration of operating systems. You know, think basic things, platform level things like DNS, NTP, SSH, firewall, users and groups. Before you can deploy your business applications, you have to have a platform or a foundation on which to put them, and that has to be managed as well. While some of these configurations might be the same across all nodes, like DNS and NTP are going to be generally similar across localized groups of nodes, others might require unique configuration based on location and workload. So firewall, users and groups, configuration files that need to have specific IP addresses and host names in them. Regardless, Puppet helps to simplify and speed the initial configuration and also the ongoing management of these aspects of platform operating system across environments, assuring that services are in the proper state, files have the correct contents and permissions, local users are configured correctly, packages are installed at the correct versions, and so on and so forth. Beyond operating system configurations, people also use Puppet to help automate application deployments, patch and update systems, remediate configuration drift. So if one system starts to change or a local change is made, Puppet can actually identify that and move it back. Manage network device configurations, so beyond the operating system of kind of servers and more. So that's kind of an idea or a sense of the sorts of things that Puppet Enterprise can manage. Let's talk a little bit about how it actually works. With Puppet, you treat your infrastructure as code. You define the state that you want your systems to be in, and then Puppet goes to work ensuring that systems assigned a particular desired state match that desired state and stay that way. You can do this across operating system resources, virtual cloud infrastructure, network and storage devices, applications, the gamut. Puppet is first and foremost a language for writing or defining this blueprints, like definitions of what you want, and then it's a tool for deploying and realizing these definitions. So with Puppet, you can treat your infrastructure as code, but note that when we say infrastructure as code, we do not mean scripts, where you have to procedurally define every step that you have to take along the way about every possible permutation in a situation that might arise. So instead, with Puppet, you use an easy-to-read domain-specific language to define the state that you want your systems to be in. This declarative approach is unique to Puppet. So for the sake of example, let's think about this declarative model or how this would work for a house. Okay, so something simple, an analogy. For a desired state of a house, think about what it means to have a clean house. It means your keys are on the hook, your jacket's in the front closet, the floors are clean, the laundry's been put away, your fridge is well stocked, the remote control is where you want it on the coffee table. With Puppet, you use our DSL to define your desired state as is seen here. With our approach, there's no messy scripting where you'd have to list every single instruction for cleaning your house, like turn the vacuum on, walk 3 paces forward, if there's a cat in the way, move the cat. If not, then keep vacuuming, take 3 paces backward, turn slightly to the right. You get the picture. Instead, with Puppet, you start by defining your final desired state. You tell Puppet how you want your environment to look, and our software handles the specifics of how to actually make that happen. So Puppet deploys and manages desired configuration using a client-server architecture. The code, which defines the desired state, is deployed to a central Puppet master server. It's a sort of a master blueprint from which the individual configuration of any server in your environment can be derived. Every server or device under Puppet management runs the Puppet agent software, which continuously monitors and enforces desired state as defined centrally at the master. If the code describing the desired configuration changes on the master, every Puppet agent will automatically update or make changes to its node as necessary to ensure that the enforced configuration on managed systems stays in sync with a central definition. In the infrastructure as code theme, updating the Puppet code deployed to the master has the effect of updating the configuration of your entire infrastructure. Your infrastructure effectively is or can be treated like a deployed application. Puppet masters can also have multiple versions of code deployed simultaneously and use it to manage different logical environments. Just like you might deploy a new version of an application to a test server, you can deploy new versions of your entire infrastructure's definition, configuration, to your development, test, QA, or production environments. As your infrastructure changes are tested and approved, they can be promoted from environment to environment the same way an application version is, using the same kind of tooling and methodologies. Puppet code, as you've seen earlier, is plain text, and you can store it in a version control system like Git. We're not picky, you know, it can be Subversion, Mercurial, Perforce, whatever you want. It's just a tool for managing and controlling changes to code. But in this way, new features can be developed in branches, for example, and they can be merged in after automated testing of the code and peer review. When you're ready to deploy changes to an actual test or production infrastructure, you can tag and deploy a release the same way you would with an application. So the benefits of automating IT, like you just saw here, is that you can accelerate your cycle times, bolster productivity, and increase the insight that you have into your infrastructure so you spend less time fighting fires and more time iterating and deploying software. Because your infrastructure is defined in code, things like automated testing can be integrated with your infrastructure and built for your infrastructure as well. So Puppet Enterprise, which is the commercial product offered by Puppet Labs, is built on top of the core Puppet foundation. And it adds kind of the same kinds of things you'd expect, based on the model we saw from Jenkins. It's adding premium features like a graphical user interface, detailed reporting, so you can see, every time Puppet runs and enforces a change, you can get information back on what's happening across your environment. Tools to quickly locate and resolve configuration or compliance problems that have been identified by Puppet, access to enterprise-level support, professional services, and more. So the enterprise product is free for use on managing up to 10 systems and can be downloaded directly from puppetlabs.com. And it's a great way to get started with Puppet if you're kind of curious of how the technology works fundamentally. So that's kind of the end of the introduction to the tool. In summary, Puppet is a tool for writing self-enforcing definitions for what each piece of your IT infrastructure should look like and for deploying and enforcing those definitions. It's a different way to look at and manage your infrastructure. It allows you to iterate rapidly and make use of methodologies and tools that are or are part of mature development processes. It's infrastructure as code. Harpreet?
All right. Thank you, Reed. Just wait for control to come back to me, and it has. And okay, so now we have seen Jenkins and we've seen Puppet. So let's get into the first use case, and we call this use case as traceability. And let's assume the underlying things for this use case is we assume that you've used Jenkins to build stuff, and you're going to deploy using Puppet. And this traceability piece ties these two pieces together. So what happens today when we talk about dev team, and dev team has built this and they handed off the bits to the ops team. The first use case is the ops deploys it, and if things go wrong, the ops team using Puppet can pretty quickly roll that back, right? That's the advantage of Puppet. You can roll back to your previous version, and Puppet would take care of deploying these things for you. However, if you're moving from dev and ops to DevOps, and going back to my use case of the ops guy looking over the shoulder of the dev guy and saying, hey, how did this land in production? What happened in the build stages? The bits went from dev to testing to QA, and we've still ended up with something wrong. How did that happen? And this goes to the global maximum because now there are different organizations in play. So how can the ops guy come back and tell the dev guy that, you know what, this went wrong and this is the reason why it's gone wrong? So that's not available today. The other part of the story is the dev guy. So let's say dev guy is building a library and it depends on some other library, and this library, his library is in production, and a security alert comes by on the underlying library, and he needs to now figure out and go to the ops guy and say, like, look, my library, which depended on library foo, has changed. You need to go and change these servers. That piece is missing as well, right? So if you look at the software delivery life cycle, I like to think of the CD story as a bunch of chefs. Each organization is doing something to it, and they have touched upon it. It has gone from one stage to the other. Everybody has done their own thing, and the key is figuring out how did the bad fish land up onto the customer's plate. And this is where the first the integration with Jenkins and Puppet comes in. And so Jenkins has this notion of called the fingerprint, and that's a fancy word of saying that Jenkins can actually keep track of all your files that are artifacts that are being produced, and can create it creates an MD5 hash of each of these files, and it keeps it in its fingerprint database. So now a developer comes in. So if you're using, say, a Maven job, those are automatically fingerprinted for you. If you're using another type of job, those are fingerprinted explicitly. You have to call that out. So now the dev guy comes in, he builds the stuff, he pushes this to the repository, and the ops guy comes in, and the ops guy deploys this code. So what this plugin, so there's a plugin out there called the Puppet plugin that builds on an underlying infrastructure plugin that we call deployment notification plugin. So what the Puppet plugin does is it notifies it, Puppet, when you deploy and you run a Puppet apply command, you can actually point and create reports. So what the interaction does is it lets you post these reports back to Jenkins. And Jenkins now understands these reports, and then it looks up the artifacts that are deployed, and then it matches them within its own database, its own fingerprint database, and it sort of pushes that out onto the build information. So just doing that actually enables both of these use cases to happen, right? And the reason, and I've seen some questions come up, is Puppet orchestrating Jenkins, or Jenkins orchestrating Puppet, or is Puppet going to rebuild stuff? And kind of going back to one of the main underlying points with continuous delivery is you shall build your binary once. That's it. So the binary has just been built once. There is no heavy interaction between the tools because these tools work somewhat differently, but they need to work together. So this reporting mechanism and this fingerprinting mechanism ties these two together. So, and it's actually very surprising how easy it is to end up using it. And there's a more interesting story about this while I bring up my demo is this kind of interaction can only happen in open source. As our infrastructure team started looking at using Puppet to deploy Jenkins infrastructure, which is the next use case, we figured that, hey, this part of the story is missing. We reached out to the Puppet guys, and they pointed us to the code. We looked at the code. We contributed the code back, and boom, this open source interaction sort of helped push this forward. So that's just a fun story aside. Now let's get into the demo on how you would actually set this up. So I'm going to share my desktop at this point. And what I have is a Jenkins job. It's a standalone standard job that's running, okay? And what I've done is I have installed the Puppet plugin on it. And if I look at the job configuration, although this is a Maven job, it should really set up fingerprinting for the archives that are generated. I'm explicitly in the post-build action, I'm explicitly saying that, hey, for this Java application, the traceability.war that gets generated, that's the name of my war file that gets generated, I want you to archive the artifacts. Once I do this, the fingerprints will be generated for that. So I've done that. Now, let's run this build. So it's a very simple Java application. It's building the stuff, and while it's doing that, I'll get over to to the production side of things, and this is now running on my own machine. So what I've done is I've mimicked the environment through Vagrant, and what my application, my WAR file is being deployed to a Tomcat instance. So what my Puppet manifest is doing, and I'm not going to go into that, but my Puppet manifest says that, well, install Tomcat, ensure that it's running, and look up the Jenkins WAR, the WAR file that needs to be deployed from the Jenkins build, and pick that WAR file and deploy that. So that's all it's doing. In a real world scenario, I would, push this artifact to a repository somewhere, a Nexus or an Artifactory repository. So I've just skipped that part out. So here we are, the build's run, and if we go onto the build page, what you'll see is my artifact has been generated, and you'll see this link here, and if you click on this small icon, that's the traceability fingerprinting link, and it kind of gives me the MD5 hash sum of that particular WAR file, but that's all the information I have, right? So my builds have been generated. Let's just say that we've gone through this process of promotion, it gets promoted, and the ops team is let know that this has been generated, it's ready to deploy. So I'm going to just provision a Vagrant machine, so it starts up. And while it starts up, let's look at the what's happening in here. So I'm using Vagrant just to start the machine on my box here, but what it tells what it does is, while it comes up, it automatically runs Puppet. It points to the manifest file. The manifest file is doing exactly what I just told earlier, which is install Tomcat, pull down this WAR file and deploy it. And then if you look at this, there is this options feature, which is the reporting mechanism, which is pointing out to the URL of Jenkins, where the Jenkins plugin now, which the Puppet plugin exposes, which is now listening to any reports that are coming in. And reports are sent back to it in a YAML format for whoever cares, but it can parse that and look at the archives that were deployed and match those up. So we are back to the provision step. What you can see that I have deployed this, and if you look at this, there is a MD5 hash sum that got generated, and the catalog has run. So if I come back to my job and my latest build, and if I go back to the fingerprinting page, what you see here is you see where this has been deployed to. So you can very clearly now see that this Puppet came back and told that it has deployed to this VM. It deployed this about X seconds ago, and it just gives you the whole location. So if I go back and I look at some of the previous builds, so if I look at, say, a build that I ran this morning, and I look at this, I can see that my last deployment before this deployment happened about 53 minutes ago, and this actually ends up tying both these pieces together, right? So if I had handed this stuff out to Reed and redeployed this and things failed, he could actually come back and tell me, hey, look at this build. That's the build that's created a problem. Then I would go back as a development team, go back and look if it's a problem with my testing environment, or if the commits are bad or whatnot, and that's how we would debug this. So that brings us to the end of the first use case, and that actually talks about how these two worlds are being provisioned. And now let's get back to the presentation. So now let's get to the, so what we've seen here is we've pushed changes, we've deployed using Puppet, and we've run some fingerprinting on Jenkins. Now let's look at the next use case, and This use case comes about from the Jenkins infrastructure, the Jenkins CI.org, how we deployed it. And the background on this one is CloudBees has held a lot of CD, continuous delivery summits all around the world. There was one, in fact, in Paris. And what we see is people have built these pipelines today, and these pipelines are sitting behind their firewall. So people come out and they talk about how they built the pipeline, and you can see that on the slides. But if you're somebody new who's trying to build these pipelines, there aren't live use cases that you can do view. So one of the goals with the Jenkins infrastructure project was to say, well, let's build a true sort of modern pipeline and push that in open source for a real world use case that people can actually look at and see how things are done and then use it. So whatever I'm going to talk about has been done in the open source by the open source community, and you can actually go to the Jenkins GitHub page and search for Jenkins infrastructure and see this pipeline set up. There are a number of other tools that come into play today in this world. So there's Git, and there's Docker, and there's Jenkins and Puppet that makes this world go together. One of the components that's being used is Docker. So for people who aren't familiar, Docker is providing you an environment now where you can containerize components. So for example, the Jenkins CI.org has a number of applications that get deployed, right? So there's the wiki that you see. There's the authentication, LDAP authentication application that's running behind where you can log in. There's the accounting application. There's the IRC bot. There's the Confluence, that's the wiki. And there are a few other applications that make up the system. And these are deployed on, I think, about 8 or 10 servers. So that's the system. Now, what Docker is coming in and letting you do is say that, hey, you can containerize each of these applications into this individual into a Docker slave, and you can bring that up and bring that down fairly quickly. There are a number of Docker plugins that are out there. So the one that's on this slide talks about Docker being used as an elastic build slave. So Jenkins has this notion of slaves. It has the notion of clouds that you can connect. So you can have a Docker cloud that connects, and every time Jenkins needs a slave, it can talk to Docker, and it can quickly spin up slaves within that environment. You can actually define the image, the exact image of your component. So it can be, say, the IRC bot, and that slave can just be brought up in that the container. The other pieces that are being used is there's a Docker publish plugin that lets you take a Docker container and push that to a Docker registry, so you can quickly look up and download containers. And there is a Docker build plugin which lets you actually build Docker containers and create Docker containers and start Docker containers as part of a build process. So, and it again goes back to this this notion of there is this plugin architecture that lets you plug in sort of the best of the world out there. There is no one prescriptive way of doing things. So what I'm outlining is one way that this team has gone about doing things. How does that workflow look? So let's take the case of the IRC bot, for example. What happens is if you need to update that, that's sitting up as a Docker container, and a Docker container is described as a Docker file, and it sits up in a GitHub repository. So when a developer checks this in, Jenkins gets notified through a GitHub poke, and it builds the Docker file. It uses the Docker build plugin to build the container. And once the container is built, you can tag each of the containers with the build number. So every container that gets subsequently built is tagged, and then you're using the Docker publish plugin to publish that to the Docker registry. So a single commit actually takes your builds right up to the Docker registry. Now, where the state of the project is, the next stage that should happen is once this build builds, there should be a number of number of tests that should be run, and I think the team is actually building those out. But this goes back to the point of this is infrastructure as code. The infrastructure has been defined in the Docker file and that's been committed in, and now it lands on a Docker registry. So let's say the IRC bot has been updated, and at this point, Harpreet, who's up there with the beard in the development team, notifies read. And before I go and talk about the ops side, what they end up using is this validated merges plugin from Jenkins Enterprise and a GitHub pull request plugin from Jenkins Enterprise. So what the validated merges plugin does is, so there is this notion of if I commit a change, I need to run tests, and I need to run these tests on my box and make sure everything runs, and then push my changes upstream to the repository. The second thing I would need to do is actually get somebody to do a code review to make sure that things are fine. And I think that worldview is somewhat broken, and validated merges solves that. And why is it broken? So one, as a developer, what you want to do is actually just push changes in and let the Jenkins infrastructure take care of making sure the right bits land. So in this case, what happens is when there is a repository that validated merges plugin runs on Jenkins, and the end developer actually pushes that to the, instead of pushing it to the upstream repository, pushes it to the Git repository. Jenkins actually merges the changes from upstream, makes sure all the tests run, and if they run, it automatically merges it upstream. And if they don't run successfully, it notifies the developer. So no bad commits actually ever make it to the upstream. And you actually don't need code reviews in this scenario, because if your build is broken, that obviously means that things aren't fine. And and ideally somebody just reviewing code is not going to catch those things. They can talk about, yeah, this design isn't great, but they can't catch these kinds of things. So it's like letting Jenkins do that stuff. And then there is the pull request plugin, which builds on top of validated merge. And what it does is it sort of works closely with GitHub. So if you're using GitHub, the pull request plugin gets, if I submit a pull request to GitHub, which is the GitHub parlance of saying, hey, I forked this, I made some changes, and I'm now going to commit this, and I send it to the main developer there on the other side. I get a pull request, and the pull request plugin gets notified. It pulls the changes out. It builds on validated merges, it tests everything, and if things are successful, it actually posts back to GitHub saying that there is a successful build, and this should be merged in. And then the main developer can actually just merge in. So going back to the scenario where the dev team has pushed things to the Docker registry, the container has landed up, and the ops team comes in, and it maintains a number of Puppet manifests that describes the environment. And in the Jenkins infrastructure world, so the manifest is needed to say here, it points to this container. That's the container that needs to be started up. It needs that port to be started up on. It needs to be on those kinds of nodes, and so on and so forth. So read will come in, and he will actually update the manifest with the latest Docker container tag that was produced in the earlier cycle. That will show up as a pull request to Jenkins. Jenkins will build it, and once it's built, it will push it out. So the first thing that happens here is, this is infrastructure as code. Somebody has made commits to their manifest. And the first thing that happens as part of the pull request is we run unit tests, and the unit tests are run with something called rspec puppet. And I'll call Reed to comment on what rspec puppet does to help people understand that.
Sure, Harpreet. Well, rspec puppet is so rspec, I guess, to start at the beginning, is sort of a Ruby unit testing framework. rspec puppet is an extension that allows you to write tests and assertions against what puppet compilation should be produced. When you write a puppet definition, it typically has a lot of, if you're on a Red Hat server, do this. If you're on an Ubuntu server, there's a slight variation. If you're on a Windows server, do something completely different. And all of those variables and logic is used to produce an artifact called a catalog, which actually contains the definitive configuration that should be deployed. So with rspec puppet, you can write tests and say, if a node of this operating system checks in and it receives this classification, for example, it says you should be running the IRC bot. You can write an rspec puppet test, unit test, to basically validate that the configuration you expect will be produced. If an Ubuntu server should be running this, then I expect that Puppet will tell it to have this configuration file in this package. If a Debian server is going to be running it instead, I expect that the file location will be slightly different. So it's unit tests for Puppet code. Make sure that the catalogs Puppet produces, the node-specific desired state, meets my kind of predefined test expectations.
Okay, thank you. And so now we've sort of run the unit tests, and it kind of gets to the next stage. If the unit tests are successful, there's another Jenkins job that actually provisions this IRC bot on a machine somewhere on EC2, and we internally end up using a vagrant to do this to start the machine on EC2. And these tests are written in serverspec. And again, Reed, enlighten us with serverspec.
Yeah, so we talked about rspec puppet, and that was unit testing, make sure that the desired state we're going to ask for is what we expect it to be. But serverspec is more about acceptance testing. It's so we deployed the code, Puppet laid something down, configured a machine, but how do we know that the service at the end of the day is actually running? Puppet made sure that a process was started, but is it listening on port 8080? Is it serving a welcome page with the appropriate source of content? So serverspec can be used to write those sorts of assertions. Things like there should be something listening on port 80. If I query it, I should get a result back like this. There should be, there should exist this file. And so serverspec isn't going to be able to enforce or actually affect changes like Puppet is, but it will be able to make more kind of deeper application level just checks to make sure that not just that the system matches a given state you've described, but that the given state you've described actually results in a functional server or application. This is often combined with Puppet. So Puppet sets up and can configure the machine, but a serverspec test suite is written to make sure that whatever Puppet actually hands out the door functions as expected.
Okay, so in this case, this would mean that the IRC bot has come up. Is it serving request or not? And once that's happened, we move on to the next stage of the pipeline. And the next stage of the pipeline is so all of these commits, think of them are happening on a particular branch. They are not happening on, say, the master branch. And this is happening on a staging branch, and the staging branch has a corresponding environment associated with it. And this pull request finally makes its way here, and Puppet Enterprise actually spawns off a bunch of machines. So one of them will have IRC running on it, and the other one would have the wiki running on it, and it would set all of these up in staging environment. And at that point, we have to go in and look at things and do a final user sort of acceptance testing to make sure things are running fine. And what we end up using for this is R10K and the dynamic environments feature from Puppet. And again, I think Reed is the best person to talk about that here.
Yeah, and Harpreet, actually, R10K is a relatively complicated thing to talk through. I have a visualization that might help if you can pass control to me just briefly for a second.
Sure. I think Alyssa will have to do that. Yeah.
Okay, there we go. So go ahead and share my desktop here. All right, let's see. Cool. So I'm just going to call back to this slide for a second. I mentioned that Puppet is capable of serving sort of multiple versions of code simultaneously to different environments. R10K is basically a utility that will automatically map this visualization is kind of showing, it's a little rough, but it's showing a Git repository in different branches and commits. R10K is a utility that maps the tip of every named branch or branches that you've defined as representing an environment to an actual Puppet deployment, which means that if you do things like you're working on a feature branch, you commit code, when that goes to the central Git server and it's merged, whether through Jenkins or some other system, it's automatically deployed to the Puppet master as a usable and functional Puppet environment, at which point if test nodes are spun up, they can check in against it and receive configuration directly from that code. So we also have in this example, we have the dev branch, which is deployed to Puppet environment, and the production branch, which is deployed to Puppet environment. And the end result of this R10K kind of making this sort of mapping is that you have the ability to drive deployment of your Puppet code directly through Git. So your Git workflow, where you have different branches representing different stages of development, QA, UAT, production, et cetera, anytime you have tools and methodologies around promoting that code in your repository, R10K can automatically reflect the changes that you've made, that you've driven through Git or your version control system, and implement them on the Puppet master and deploy the code to the actual master system. R10K is a pretty complicated subject, and I can give a link at the end of the webinar for more information, but that's fundamentally what it's about, is automatically mapping a Git workflow and Git branches to deployed Puppet environments in Puppet code.
Thank you, Reed. All right, Alyssa, can I have the control back? And all right, so coming back to the slide here. So what's happened in this, as Reed pointed out, right? So each of these branches automatically becomes an environment, and so the way the Jenkins infrastructure runs is there is a staging branch on which all of this happened. And once those things came up, Puppet Enterprise actually automatically deployed that onto the staging environment. We checked it, we think things are okay, and at that point, we just do a git merge of the staging branch onto the production branch and push that changes out. And because it's again tied back through R10K and Puppet Enterprise, Puppet Enterprise can go in and automatically deploy all that has been made, all the changes that have been made to a production environment. And because, as Kosuke likes to point out, the founder likes to point out, Jenkins is an open source project. It is too expensive for the project to keep 2 environments running all the time. The staging environment is brought down. So to kind of capture all of these things back again, so what you saw is sort of this end-to-end deployment pipeline that started from the dev team using tools like Jenkins and Docker to containerize components, keeping the notion of infrastructure as a code. The code was pushed into the environment, into the repository, and the ops team was notified of this, and the ops team has come in and deployed, used and created an environment for each of these check-ins, and eventually deployed the branch to production. So with that, this brings me to the end of our presentation. So if you haven't looked at sort of building these kinds of pipelines, I would suggest looking at both Jenkins and Puppet if you're using one or either of these tools to use the traceability feature to connect these to get end-to-end visibility of how your pipeline should be. In terms of next steps, I'd like to call a few things out. So we have a enterprise version of a 30-day evaluation copy. Puppet has a enterprise version available for trial. And there are 2 conferences coming up. The Puppet conference is right around the corner in the next 2 weeks. And the Jenkins user conference is next month. And the traceability example that I talked about is available as a write-up at that link, and it shows you how to actually just set the whole environment up. With that, I'd like to call an end to this. And Alyssa, are we taking questions or?
We're actually out of time, so we will not be taking questions. But however, feel free to input your questions in the Q&A window. We will compile these and put them in a blog and send it when we do our follow-up email. So in closing, I just wanted to say thank you to Harpreet and Reed for today's webinar. I want to thank especially our attendees who spent the time with us today to learn more about Jenkins and Puppet. Like I mentioned, please go ahead and continue to put your questions in the Q&A window or your comments. I will leave the window open for a few more minutes, and then we'll compile it and we'll send you our response in the follow-up email. So thanks again, everybody, and have a great day.
Thank you.